Solve the following equation. Absolute value of x squared minus 4x equals 2x minus 3. For this absolute value equation, the absolute value expression is quadratic. We still solve it by separating the equation into two cases. These cases are based on the sign of the expression inside the absolute value symbols. We then solve the resulting equations for both cases, remembering to reject extraneous solutions. These correspond to solutions that are inconsistent with the given case being solved for. Looking at the expression inside the absolute value symbols, x squared minus 4x, we have to consider when x squared minus 4x is greater than or equal to 0 and when it is less than 0 in order to separate this into the two cases. We can factor f of x equals x squared minus 4x into x times x minus 4. This means that the x-intercepts of the corresponding function would be at x equals 0 and x equals 4. If we were to graph this, this would correspond to a parabola opening upwards. We can then look at case 1. Case 1 corresponds to x squared minus 4x, the expression inside the absolute value symbols, being greater than or equal to 0. Looking at our graph, we can see this corresponds to x being less than or equal to 0, or x being greater than or equal to 4. For this case, we replace the absolute value of x squared minus 4x with x squared minus 4x and solve the resulting equation. Subtracting 2x from both sides and then adding 3 to both sides, we then have a quadratic equation with 0 on the right side. This equation does not factor, so I will solve this using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Substituting this in, we get 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 3, all divided by 2 times 1. This gives a result for x of 6 plus or minus root 24 divided by 2. Note that root 24 can be written as root 4 times root 6. And then that root 4 is 2. We can then simplify this to x equals 6 plus or minus 2 root 6 over 2. We can then divide each term on the top and bottom by 2, canceling out the 2's, giving x equals 3 plus or minus root 6, or x equals 3 minus root 6, or 3 plus root 6. We then have to check each one of these solutions to make sure that they're not extraneous. 3 minus root 6 corresponds to approximately 0.55. Note that 0.55 is not less than or equal to 0 or greater than or equal to 4. We then have to ignore this first solution. The second solution here, 3 plus root 6, is approximately 5.55. This is, in fact, greater than or equal to 4. This means that this is a good solution. We then move on to case 2. For case 2, it corresponds to x squared minus 4x less than 0. Looking again at the graph, this corresponds to x values between 0 and 4, 0 less than x, less than 4. For this case, we change the absolute value of x squared minus 4x to negative x squared minus 4x, and we still make this equal to 2x minus 3. Here, we can divide both sides by negative 1. This results in x squared minus 4x equals negative 2x plus 3. We then want to move everything over to the left side. We can add 2x to both sides and subtract 3 from both sides. This gives us a resulting quadratic equation of x squared minus 2x minus 3 equals 0. This quadratic expression can be factored. We're looking for numbers that multiply to give negative 3 and add to give negative 2. These numbers are 1 and negative 3. We then have the factors. X plus 1 times x minus 3 equals 0. These correspond to the solutions x equals negative 1 and 3. Again, we have to check these two solutions. For x equals negative 1, note that this is not between 0 and 4, so we must reject this first solution. 3, however, is in between 0 and 4, so this corresponds to a good solution. Overall then, our solution to the absolute value equation, x equals 3, or 3 plus root 6.